Hi, in this lecture we'll try to understand what are variables, mutability, constants and shadowing in Rust. I have already posted the notes in the Notion doc, feel free to go over it, but I'll explain it hands-on as well. So if you have worked with any of the programming languages like Rust or JavaScript or Java or C++, you might be quite familiar with what variables are. For those who don't know or don't remember, variables are entities inside a code block which basically contains your information, and this information can be changed as per the code. Actually, it keeps on changing, or it can be constant as well. Now, in Rust, variables are mutable by default. So once you have assigned a value, you cannot change it unless you explicitly say so. This helps prevent bugs and makes code easier to reason about. Actually, now enough of uh, talking. Let's understand what exactly I mean. I'll remove the previous code. Probably I should turn off the auto completion as well. Okay. Now, say suppose we declare a variable a. In Rust, we use let to declare variables, and if I declare a variable a in Rust, it basically becomes a immutable object or immutable variable. An object will be a too big definition, but an immutable variable is something what a is here. What do I mean by immutable? Uh, Immutability means you cannot change the value. You cannot assign a new value to the same variable actually. But here in Rust, if you cannot assign a value, what happens if I assign a value? So say suppose if I'm writing print ln value of a, and then I'll try to print the value of a. Okay, now what I'll do is I'll do cargo build. The build is successful, so there are no compilation errors. I'll do cargo run. Here you can see the value of a is 7. Now I'll do some changes. I'll say a is equal to 8. Say suppose. Will it compile? Let's see. No, because you cannot assign an immutable variable a value twice, and if you do it, your code will not compile and you will not be able to run it. So this makes a immutable variable actually. But what if I want to change the values? How do I do it? Now if you want to change the value of a, let's say I'll delete this part. I'll say let b is equal to 8. Okay, now I want b to be a mutable variable so that I could change its value. What I would do is I'll add mut, a keyword mut, which is responsible for making this variable be a mutable variable. Now if I save this, and what I'll do is I will do a println again, value of b. I'll save this. Let's try to compile this. Okay, since it is a mutable variable and we are not changing its value, making it mutable does not make sense. That's what the compiler tells us. Now what we need to do is we could change the value as well. B is equal to 9, but I'll do something. Let's say try to print the values consecutively. I'll also remove this part, paste it here. Now I'll try to build it. The build goes fine, and then we try to run it. You could see the changes in values of b. The value of a remains same, the value of b is 8, the new value of b becomes 9, which means b is now an immutable variable because we have assigned mut keyword into this particular variable's declaration. Now the next concept is more about using constants. You might have come across this across many languages. So constant is something which has a constant value, and the value does not change across the whole program or across the whole code base. There is a specific way or industry standard of declaring constants in Rust, which is each and every word in that specific variable should be a capital letter one. So it should be in block letters, to be very precise. So say suppose I want to create a constant day of month. which is, or you could say days of month. It should be 30 or 31. Let's say 30 it is. If I want to print and number of days in a month, it should be days of month. I'll basically save this, and once I build it, okay, one more thing about constants is you have to decide and you have to assign a specific data type. Now we have not covered data types till yet, but in the next lecture I'll cover the data types. But if you want to assign, for this purpose I could assign it i32. I'll explain i32 in the next lectures, so please be patient. So i32 is basically a particular number in Rust. I'll go deeper into the next one. So I'll build it, the build is successful, and I run it. So if you could see, the number of days of month is quite visible here. But say suppose if I want to change it, like I'll say days of month is equal to 31. Will I be able to compile it? Let's see. No, because days of month is a constant and you cannot change its values. So this is quite clear. I'll probably delete this part. Now the last part which I want to discuss with you is the concept of shadowing. Now Rust basically provides you a new or a more optimized way of changing the values of variable, and it is called shadowing. Let's go with the documentation first and then we'll do some hands-on on this one. Now if you redeclare a variable with the same name using let, each let will create a new binding and the old one will be shadowed. What do I mean with this? So say suppose if we have let a equal to 7 here, and we do let a is equal to a plus 1, which means we are incrementing the value of a by 1 unit. Now will this compile? Yes, it will, because we are shadowing the value of previous a with a plus 1. Now a will have a new binding with this reference actually. So if you do a cargo build, the build succeeds, and you do a cargo run, you should see, or you could see here, the value of a is already 8 once we are printing it here. Now has the variable become mutable? I won't say so. It's not mutable yet, because if I do a is equal to 9 and I do a build, it still remains immutable. But since we have initiated the variable again, the binding changed from the previous variable and it got assigned a new one, but it still remains immutable. Another thing with shadowing is you can change the data type as well, or you can change whatever you have worked with. Like just for example, if I have a variable called spaces, just what I have written in the example, and I assign 3 spaces to it, and what I'll do is let spaces is equal to spaces dot length. So dot length is a function in Rust which will basically calculate the length of the spaces, or length of the string actually here. Now ideally what you could see here is spaces is a string, it's a string variable, and it should not be extended to any other type. Like this length will return me a number actually, or i32 or any kind of number, right? Because it's a length of the string. But if I do it using shadowing, it will still work. And if I compile it here, cargo build, okay, there is no intentional, so I need to use this variable as well. Println, what I'll do is number of spaces, and I need brackets, and I'll do spaces and a semicolon. Yep. So if I do a cargo build, the build goes good, and then we run it. So you could see the variable which was actually a string has now been converted into a number actually. So that's the impact of shadowing. But there is a catch. You cannot do the same thing with mutable variables actually. Let me show you with an example. So the spaces variable which we have, which is of data type string here, which has 3 spaces and which has been used as a shadow or assigned a new value or a new data type using shadowing principle of Rust. If I make this a mutable variable using the keyword mut, now what will happen here is it will basically change the type of variable. It will become mutable, but we cannot assign a different data type to it. Why? I'll show you. So what I'll do is I'll do cargo build. You could see here, since this particular mutable variable was assigned a string value, and here the length function will give a number value, you cannot change the data type of mutable variables. So it will not compile itself. Rust will not allow this to compile. Hence, mutable variables cannot change their data types, but shadowed variables can change their data types as well as values. Mutable variables can only change their values actually. I have a descriptive table here, which is a summary for all of them in case of immutable variable, mutable variable, constants, and shadowing, and how do we assign them values. Now coming to the best practices, we should prefer immutability for safety and clarity. We should use mut keyword only when a value is meant to change. Like if you want to change the value of a from one value to another, use mut keyword. If you want the value of your variable to remain constant across the code, then use constant. Use shadowing or transformation or type changes without cluttering variable names. So don't use it too much, but we'll see examples where we do it in the next lectures. So this was more about variables, mutability, constants, and shadowing. Thank you. See you in the next one.